Dear students, today we will be discussing about the components of repetitive control. So we have already discussed about the loops and how we can control, but we will formally define that what are actually the components of a loop and how we can control those components. So first component is initialize. Establish an initial value state that will be modified toward the termination condition. Second is the test. Compare the current state to the termination condition and terminate the repetition if equal. And third step is modify. Change the state in such a way that it moves forward the termination condition. So for example, when we write number is assigned 1 and while number is less than equal to 10 and we say print number and number is assigned number plus 1. So basically the first one is the initialization. We have initialized, establish an initial state that will be modified. So this need to be modified. So we are modifying this at the last statement toward the termination condition. So here we have written plus 1. We have not written here minus 1. So what will happen if we write here minus 1? This means we are not moving toward the termination condition because it's already 1. So if you form a number line, here we have 0, 1, 2, 3, 4, 5 and so on, and here we have negative values, minus 1, minus 2, minus 3, minus 4 and so on. So if the initial value is 1 over here and we are saying number is less than equal to 10 and we are decrementing the number by minus 1, so this means this 1 will become next time 0, next time it will become minus 1, minus 2, minus 3, minus 4, minus 5 and so on. So can you see that any time it will reach until 10? No, because 10 was in this direction, not in this direction. So that's why you need to choose something that is moving toward the termination condition. Then we are testing, here we are testing while number is less than equal to 10, and then we are modifying this number over here. So there are some finite loops and there are some infinite loops. So we will be discussing some examples of finite loops which will end whenever we want. For example, we have now our problem is that we want to print 0, 2, 4, 6, 8, 10. So what we can write? Number is assigned 0 while number is less than equal to 10. Number is printed and the modification number is assigned number plus 2 because we want the iteration of 2. So you can see that in RAM the number has value of 0 initially and then it will be adding by 2. So next time it will have 2, it will print 2, then it will print 4, 6, 8, 10, and when this number is 12, then this loop will be terminated. That's perfect. However, the same loop can be redesigned with a little bit trick you will see, like we have number is assigned by 1 while number is less than equal to 10, print number, and number is assigned number plus 2. So let's see what will happen now. We have a RAM, and here is a location that is called number, and this number has initially the value of 1, and that is going to be incremented by 2. So next time it will become 1, 3, then it will become 5, 7, 9, 11, 13, and so on. So when it will become 11, so 11 is less than equal to 10. Condition will be, because 11 is greater than 10, so condition will be false and this loop will be terminated. However, if we write at this place number is not equal to 10, until 10 we want to execute, then you can see that in this pattern we have not found 10 anywhere. So this means this loop will become an infinite loop, and this loop will not terminate any ever. So this will keep on running. So such loops are known as infinite loops, and you need to be very conscious about how you have initialized the values, what is the condition which you are checking, and what is the modification you are making. And then you should check this thing on paper whether it is up to the mark and actually on the same line whatever you want. So if we summarize today's module, we have learned about components of repetition, and we have discussed finite loop example and infinite loop example, and there could be number of many examples through which the infinite loops can be constructed.